Hi, everybody. Good afternoon or morning, depending on where you're joining us from. Thank you so much for joining us. I really appreciate it. Let me just go ahead and share my screen because I don't think I am. Let's see. Ola, can you just confirm if you can see my slide?
Yeah, I see it.
Okay, awesome. I'm here with my colleague Ola Ekdahl, and he's going to be presenting about Kubernetes administration and also talking a little bit about becoming a certified Kubernetes administrator, CKA. And he is the perfect person to talk about this because he is one of our expert trainers in Kubernetes. So we're going to start here in just a moment. I just wanted to let you all know that if you're interested in any upcoming webinars, which we do have scheduled, you can visit our website at webagesolutions.com/webinars. And if you're interested in any past recordings, we've got some really great webinars listed up at our YouTube channel, just WebAge Solutions Inc., and you'll be able to find that and everything that we've done in the past. Just to tell you a little bit about us, WebAge Solutions, we've been in business for over 20 years. We do a lot of corporate training for enterprise clients. We train staff members, team members, and even entire organizations. So if you're interested in any sort of upskilling, reskilling, even an entire learning path program, definitely get in touch with us and we can help you out. We've done a lot of learning paths and upskilling training with AWS, Agile, DevOps, enterprise architecture, Microsoft microservices, a lot of technologies, and of course, DevOps with Kubernetes, Docker, and how to become certified. And we do a lot of Kubernetes and CKA training, and you can see all of our courses at webagesolutions.com/courses/Kubernetes-training. I'll put that in the chat too. So Ola is going to talk to you about this, and he really is the perfect person to have on this webinar. He's got expertise in Kubernetes, but also Java, .NET, Angular, React, other databases. So he's very, very well-rounded in his knowledge. He's also a Microsoft certified trainer, an AWS authorized instructor, and a Linux Foundation authorized instructor. So he kind of runs the gamut of a lot of things that we teach and can answer tons of questions. He does teach WebAge's Kubernetes training, including our entire training program. And I'll put this link in the chat as well, webagesolutions.com/CKA-training-program. So you'll see two Kubernetes administration classes. They're both, they say 5 days, but the CKA training program is actually a lot more than that because you get time with the instructor outside of class, time in the sandbox. You get 2 vouchers. We know you're going to pass in the first attempt, but just in case, you get a double shot voucher and some other value add. So I'll put all of those in the chat as well. But let me go ahead, turn this over to Ola so he can dazzle you with Kubernetes. All right. Let me make you presenter. There we go.
All righty. Thank you very much, Anne, and welcome everyone. Hopefully you're all seeing my screen here. I can confirm that yes, you are. So these are the topics that I would like to cover here in the next 57 or so minutes. Instead of doing a number of PowerPoints, I'm going to keep this entirely within a whiteboard, and I'm also going to do a whole bunch of demos. So really quick, we'll talk a bit about why Kubernetes, a bit about the architecture. We'll look at some common Kubernetes admin tasks, and then we'll pivot a bit and we'll talk about the certified Kubernetes admin exam, give you some tips and tricks, and just kind of introduce what that's all about. And a little bit about some resources that are available to get you ready for actually taking that exam. So without further ado, let's go ahead and get right into things. And I would like to start off here. We're going to talk a bit about why do we care about Kubernetes. Kubernetes, as you may or may not know, is a very popular technology. I'll move that other way a bit. Why is that? Okay. So let's say that we have an application of any kind. It doesn't have to be a web application. It could be, but it could be a desktop application. It could be a background service. It could be a web service. It could be something that runs on Linux, that runs on Windows, that runs on Mac. It doesn't matter. It's some type of application, something of any kind, and I want to be able to run that application. And the application itself, it could be developed in whatever language. So it could be a .NET application, it could be a Java application, it could be a Node application, it could be a Ruby application. Point is that it could be any type of application in whatever programming language that is being used to develop the app. What is it that I would need in order for that application to run? Well, any application, just to function, is going to need access to compute. What do we mean by that? Well, it is going to need to have access to memory, or RAM, if you call it that, and it's also going to need access to a CPU. Without these two things, computers do not work. Applications cannot run. They need to have access to compute. This is just kind of the basics of how computers work. Now, they are probably, most likely, going to have access to some type of storage as well. So that would be some sort of disk, local or remote disk. It's not technically required, but without having access to storage, applications would not be able to persist data. So every time the application shuts down, the data would be lost, any data that that application is keeping track of. So typically we would need to have access to storage as well. So any application of any kind on any operating system, in order for them to work, they need to have access to compute, memory, CPU, and they're also going to need to have access to storage. Now, what does this have to do with Kubernetes? Well, if you think about an environment where you deploy applications, how do you provide access to compute and storage? Well, there's several different ways of doing this, right? One way of doing it is that we create one or more, we provision, set up one or more servers. Again, Linux, Windows servers, and then we deploy our applications onto those servers. Now, these servers, they could be on-prem servers, so things that we manage. These could be servers that exists in the cloud, AWS, Azure, Google Cloud, etc. We take our application and we figure out, okay, what is it that my application is going to need besides compute and storage in order to function? So in addition to compute and storage, it's also going to need to have access to some sort of runtime. So let's say that I have a Node application, for example. And in order for me to deploy that application, it's going to need to have access to a Node runtime. So if this was a .NET application, it will need to have a .NET runtime. If it's a Java application, it will need to have access to a Java runtime, etc. Now, it's not just the fact that there is a Node runtime, a .NET runtime, a Java runtime. There's lots of versions of Java and .NET and Node. So we need to make sure that not only do we have a runtime, but that we have the correct version of a runtime. And in a larger application, there might often be the case where we have a need to support multiple different runtimes. So you are using a Node version 14, you're using 18, this application is using 20. So if I have a server, I'm going to simplify things here a little bit. Then let's pretend that we only have one server within the organization. Chances are that it's going to be many more than that. But let's say that we have one server. Then on that server, I would have to make sure that I have all the different runtimes installed. And in addition to that, any other software dependencies that my application is going to be dependent on. That's quite a bit to manage, different versions of things, different versions of software dependencies. And this is where containers can come in very helpful. Because what I can do now is I can say that, you know what, I'm still going to need to have access to compute. So I can have a server, the server, Windows or Linux server, excuse me, it will provide compute resources and most likely storage resources as well. But instead of me making sure that I have all the appropriate, .NET and Node and Java, etc., runtimes and other software dependencies installed on that server, what I can say is, you know what? I am just going to make sure that on this server, I am going to have a container runtime installed. What does that mean? Well, it means that I can now take my application, and again, let's say that this is a Node application. That's what I'm going to show in my demo here in just a few minutes. But again, it could be Java, .NET, it could be any type of application. And what I can do is I can take my app plus the Node runtime of the correct version, Node 18, 20, 14, 16, whatever version of Node I need. So the app plus my Node runtime plus any other dependencies, abbreviate that a bit, any other dependencies that I'm going to need. And what I'm going to do is I'm going to package this up into what we call an image. And once I have this image created, it is going to contain not just my application, but anything else that application is dependent on in order to function. And I can take that and I can deploy that to any server where I have a container runtime installed. As long as the container runtime is there, I can deploy my image. Now, the benefits of this is that I don't have to manage a bunch of different dependencies and runtimes on the server. I just have to say, hey, let's make sure we have a container runtime. And then the developer can package the application with anything that is necessary for that application to function and deploy that onto the server with the container runtime. And I can now do that for all sorts of applications. The only thing the server cares about is that, hey, as long as you give me an image that is packaged up in a certain way, I'll run that for you. I provide compute and storage resources to that image. Inside of that image, it can be a mix of different apps and runtimes and software dependencies, etc. And what that means is that it's a lot easier now to manage. Again, let's assume here, just to simplify things, that we have one server. It's a lot easier to manage that one server because I don't have to install lots of different runtimes and versions of that and manage and conflicts and this runtime over here has these dependencies, but this other runtime has these other sets of dependencies. I don't need to deal with that. I just need to make sure that it has the container runtime installed. Let's take this for a spin. Let's do an actual example here. So I have an application. Again, it doesn't matter the type of application that we're working with here. The fact that this is a Node application is not important. If you're not familiar with Node, then don't worry about it. We're not actually going to look at code. I'm just showing you one of the files for this application where we have a little bit of code, but it could be a .NET, a Java, a whatever application. What I'm going to do is I'm just going to run it. And right now, I am running this application by itself, meaning that there is no images, there is no containers, there is no Kubernetes involved at all yet. It's just the application by itself running on my local machine. So I am going to start the application, and we are going to just take a look at it. The application here, it is a sample application that I use for various courses that I teach. It is called the SWAPI, that stands for the Star Wars API. So it's an application that I can use to query Star Wars data about characters and films and vehicles and whatnot. Again, what the application does is not important, but this is the application that we are going to work with. And again, right now it's just running on my local machine. Let me go ahead and open it up in a external browser here on my local machine. There it is, it's running. And what I'm going to do is I'm going to take this and I'm going to go through the motions of deploying this into Kubernetes. So let's go ahead and stop running the application. And I just want to show you here that if I stopped running the application on my local machine, so now if I try to refresh the page, it's going to time out because it says, well, there's nothing running on that particular localhost port 3000 anymore. Okay, so what I'm going to need to do here is I need to, first of all, package this up into what's called an image. Why do I need to do this? Well, the reason why I need to do this is because eventually when I deploy this into Kubernetes, which I haven't done yet, but eventually when I deploy it into Kubernetes, one of the things that Kubernetes is going to expect is the thing that I deploy, the application that I deploy, is packaged into what's called an image. And Kubernetes will then take that image and deploy that in an instance of an image. We call that a container. So ultimately, my application will run in what's called containers inside of Kubernetes. And again, inside of that container, I am going to have the app itself plus whatever runtime that app is dependent on to function, .NET, Java, Node, etc., and any other software dependencies that my application might need. Now, this particular application, it's very, very trivial. So the only thing that it's really going to need is a runtime. And this happens to be a Node application, so it's going to need a Node runtime. So what I'm going to do here is I'm going to create another file, and this is what's called a Docker file. So if you've read anything about images and containers, you might be familiar with Docker. So Docker is a company that makes tools that allows me to build and create images, and they also contain or create runtimes for running images. An instance of an image is called a container. There are other tools besides Docker that I can use to do this, but Docker I think is probably one of the most commonly used one. And also what most folks that have done, even if it's just a little bit or read anything about images and containers, they oftentimes I come across Docker. So that's what I'm going to use here. And this right here, this file that we're looking at over here, this is just instructions essentially saying that if I want to build an image, these are the things that I'm going to need. So I'm going to need a runtime. So this is me saying that, hey, this application, it's going to need a Node runtime because it's a Node application. If this was .NET, it would be .NET. If it was Java, it would be Java, etc. And then I'm going to copy some source code. So this right here is saying that, hey, go ahead and copy whatever is in this server folder. That's essentially my application into my my image. And then it runs a few other commands. It's going to open up a couple of ports so that we can connect to the application. I'm going to use this port 3000. And then it's also going to say that, hey, when you run an instance of the image, when you create a container, then this is how you start the application. So with this file, what I can do is, so what I'm using here is Visual Studio Code. And Visual Studio Code has a lot of neat things that makes it very easy to work with Docker and building images. One of the things I can do here is I can just right click on that Docker file that contains the instructions for building the image. And then I can say build image, and it is going to go ahead and do exactly that. What happens here is up on top here, it is going to ask me, well, what would you like to call this image? So I'm going to call it Swappy. I can call it anything I want to, but I'm going to call it Swappy. I'm going to give it a version number here as well. I'm going to say 3.0. So go ahead and change that, and then I hit enter. And then down here in this area, there's going to be some output indicating that what it's doing right now is that it's creating this image. Now, this image, it's done. This is a very, very trivial image, so it's built very, very quickly. If you have more complex image builds, this can take a little bit longer to build, but this is a pretty quick one. Once this image has been built, what I can do now is I can view images here in Visual Studio Code. Again, as I mentioned, has some very neat tools that allows me to work with containers and images very neatly. So here is my 3.0 image that I just built. The reason why it says 21 hours there, I just built it. You weren't asleep for 21 hours and then just suddenly woke up. The reason why it says 21 hours there is because I did build this yesterday. You can see the 1.0 just to make sure everything was going to work. And then when I rebuilt it here again, it detected that, you know what, you have made no changes. There's 0 changes to what you did when you built this yesterday. So I'm gonna put another version label on it, but it's going to reuse the same build that was created some hours ago. But this one here, this is an image. What I'm going to do is I'm going to run it. So when I run an instance of an image, what it's going to create now is a container. You can see it up here. So this is an instance of that image, something that is running. And if I go back in here to my browser, and if I refresh my browser, we can see the application is running again. It's the same port 3000. Earlier, I just ran the application by itself. There was no containers or images or Kubernetes. There's still no Kubernetes involved here. But first, I just ran the application by itself. Then I created an image, and I ran an instance of that image. That's the container. That's what we're looking at right now. And at this point, what I have is the ability to take this image and deploy it onto Kubernetes, okay? So before I do that, I'm gonna go ahead here and I'm going to stop my container that is running. And I just want to show you that once this has stopped, if I try to access the application, it is going to, so it stopped. If I go back into here, you can see that it's trying to connect, and then eventually it's going to time out. That's what we'd expect at this point. So what I want to do is, before I go on to the next step where I deploy this into Kubernetes, I would like to just talk a little bit about I would just like to talk a little bit about the Kubernetes architecture. So just to reiterate something that I mentioned before, in order for any application to run, we're going to need access to compute, memory, and CPU, right? So we need to have access to RAM or memory plus CPU. And most likely, we're going to want access to storage, because otherwise application can't persist anything. And I mentioned earlier that one thing that I could do is I could go ahead and provision, deploy a server on-prem or in the cloud. I could install a container runtime on that server, and then I could start to deploy that image that I just created. I can deploy that onto that server. The thing though is that in a larger organization, you're probably going to have lots of servers. And when you start to deploy, you probably not going to want to always just have one instance of your application. You want to have multiple instances so that you can load balance. Like I want 5 instances of my app so that I can load balance between these 5 instances. There might also be, not just as I have here, my application is essentially contained within that one image, that's the app. You might have lots of components that need to talk to each other that lives within their own containers. So I need to have container A that talks to container B, that talks to container C, etc. And you want to apply perhaps various types of network policies so that you can control which containers that can talk to other containers. You want to be able to control ingress and egress. You try to do this across lots of different servers. You also want to make sure that if I deploy an application and I want 5 instances of that application, we want to be able to load balance. I mentioned that a few seconds ago. We want to make sure that not all of those 5 instances ends up on the same server. A lot of times you want to distribute, you want to spread out your instances across multiple servers so that not only do we get load balancing, but also we get some sort of high availability. Like if this server goes down, it doesn't take down the entire application because I have other instances of that app living on other servers. Now, there are ways for me to manage all of that myself. The deployment of multiple instances and load balancing and high availability. What happens if one application instance goes down? Well, we probably want to make sure that that gets restarted. And if the server goes down, we need to restart it on another server. You know, again, I can manage all of that myself. I can manage the network policies and, you know, security just in general. However, that is a lot of work. It is not an easy feat to manage all of this. So this is where Kubernetes comes in. So the way that I like to think about Kubernetes is that it sits in front of my compute and storage resources. And it provides an abstraction of that. So my compute layer here, it could be made up of, I'm just making this up, but let's say that this is made up of 19 individual servers. And then I have storage. This might be some, you know, NFS or some SAN storage, or it could be local storage on the actual servers. Kubernetes abstracts away all of that so that from my point of view, when I deploy, I don't have to say, all right, I'm going to deploy this 5 instances on, I want to make sure it's at least on 3 different servers. That's how I want to spread things out. And then I want to make sure that I manage things so that if the instance goes down, I can spin another instance up so we always have a minimum of 5. I might also perhaps want to make sure that if I get additional traffic that I can spin up additional resources. I have a minimum of 5, but I can spin up to 10 resources. With Kubernetes, I don't have to explicitly manage all of that for all of my deployments. What I say is that, hey, I have this application plus all of its dependencies plus whatever runtime that is necessary, node in my case, all of that, it's packaged up into a container. And I can take that and I can just give that to Kubernetes and say, hey, can you please deploy this to me? And I am going to give it my application packaged up, plus I'm also going to provide it with what's called a manifest. You'll see this here in a bit. The manifest is going to explain to Kubernetes, here is I shouldn't call it container, I should call it an image here. Here is my image that I want you to deploy, that I have built. Here's a manifest that explains to Kubernetes that I want 5 instances and I want it to be spread out across, a certain number of nodes within my Kubernetes cluster. And when I give this to Kubernetes, it's going to take it, deploy the 5 instances, and it also, from that point on, continuously monitors that deployment, so that if one instance goes down, it spins up another instance. If something is deployed onto a node, that node goes down for whatever reason within my cluster, it makes sure that those resources on that node gets redeployed on other nodes within my Kubernetes environments. So instead of me being so involved with like all the minutia of the deployment, I just say, here's the image, here's the manifest, I hand that over to Kubernetes, it takes it, and then it deploys that onto the compute resources that it manages. Let's see if we can make this work. So I'm going to go back into my little demo here. And where I am right now is I have my application and I have packaged that up into an image. What I'm going to do is I'm going to take this image and I'm going to push this into what's called a registry. Now, when you work with images, you work with containerized applications. It doesn't necessarily have to be with Kubernetes. There's other ways of deploying images. But when you work with images, you package things up into images, then within organizations, you're probably going to have lots of images. And you need a way of managing all of the images. And a way of doing that is to create what's called a registry. And you can access, there's public registries available that you can publish to. It's public, meaning that whatever I publish, anyone can access. You can also create your own private registries. So within an organization, you're probably not going to want to make all of your images just public to anyone to use. You can create your own internal private registries. And the point of these registries is that I can take my image, I can push it to a registry. I just did that here. And now when I do my deployment, I don't have to figure, okay, where is this image that I need to deploy? I can just say, I have this image that I want to deploy, and I want you to pull the image from what we call a registry. So when I tell Kubernetes, hey, I have this thing that I want to deploy, really what I'm telling Kubernetes is, hey, Kubernetes, look in this registry, either a private or a public one, look for this image, pull it down, and then Kubernetes is going to say, all right, I got the image. How do you want me to deploy it? Well, go ahead and look in this other thing called the manifest. And inside of the manifest, there is going to be instructions for how I want you to deploy. So let's go ahead and give this a try. And I am going to open up a terminal here. So I have on my local machine, I have Kubernetes deployed. There are various different Kubernetes installs that you can do on your local machine that are easy to use to just set up a local Kubernetes environment. The one that I happen to use here is a Kubernetes distribution called Kind. There are other ones out there. There's another one called Minikube. There is one called K3D. There's other ones besides what I mentioned here, but the point is that if you want to get started with Kubernetes and learn it, there are easy to use, easy to install Kubernetes distributions out there that you can install on your local machine, whether it's Linux or Windows. This is going to run in Linux, but this is available for Windows as well. Kind, Minikube, K3D are three common ones. I happen to use something here called Kind. And when you work with Kubernetes, there's various ways of interacting with Kubernetes. One way of doing it is to use this command line tool called kubectl or kube control. It is going to allow me to interact with Kubernetes, and I can execute various commands to see what's currently deployed. This right here is saying that, hey, give me everything that's deployed in Kubernetes, and this is on my local machine. There's not a whole lot going on right now in this Kubernetes deployment. So let's go ahead and try and deploy something. So the way I'm going to do this is I'm going to use kube control, and I'm going to say that I would like to create a deployment. I want to deploy something onto Kubernetes. I'm going to give this deployment a name. I'm going to call it Swappy. This is my Star Wars API. Now, the name here, it could be anything. I could call it Banana if I wanted to. It's just the name of this deployment. And I'm going to say that the image, remember that the image is my application plus all of its dependencies and its runtime packaged together. The image that I want to deploy is, this is my name, Ola Ekdahl. This is going to point to the registry where I deployed, or really I pushed my image. So I built it locally, I pushed it to a registry, Ola Ekdahl / and then the name of the actual image. I don't know if you remember this, but when I created it, I called it Swappy : 3.0. Okay. And lastly here, I'm going to say that this particular image, it listens to port 3000. So when I execute that command, and if I now go back and I say kube control get all, you can see here that there's some extra things added that we didn't see before. The one thing that I want to point out here is we now have a deployment here called Swappy, and it is one of one. It's ready, it's up and running. And what I'm going to do next here is when you deploy something into Kubernetes. So this is now deployed into Kubernetes. Now notice here that when I did my deployment, I didn't have to say, oh, put it on this server and do this and that when you deploy. I just said, hey, here is my image. I just gave it to Kubernetes. Again, Kubernetes, it abstracts away the compute resources, right? It keeps track of the compute resources. I only happen to have, it's on my laptop, so there's one node where everything is running. But if I have things distributed in a larger environment, then I would keep track of all of the nodes that makes up this Kubernetes cluster. What I'm going to do next here is I'm going to expose this deployment. So when you deploy something to Kubernetes, you can control if you want your deployment to be available outside of the Kubernetes cluster. That might seem weird, but wouldn't I always want it to be available outside? Well, sometimes you might deploy like services that is not accessible to users outside of Kubernetes. It's just a service that is accessible to apps running inside of Kubernetes. So I'm going to say that I would like to expose my deployment. Which deployment? Well, the one that I called Swappy. And I'm going to specify here that we do this on port 3000. And now, at this point, because I'm running this on my local machine, what I'm going to do is I'm going to explain that when someone tries to access on my local host on port 3000, then I want to forward that to port 3000 in my Kubernetes environment. Okay, so let me show you here real quick. If I go ahead and if I run this, notice that it times out, right? It says, hey, I don't know, I can't find anything running on port 3000. Let me go ahead and run this command, okay? So now what I'm doing is I'm saying that, all right, now when we access something on port 3000 on my local machine, forward that to port 3000 in Kubernetes. And voila, this right here is my app. This is now running in Kubernetes on my local machine, on Kubernetes on my local machine. Okay. Now, again, the point here, the key takeaway here is that I don't need to really know about servers and server names and deploy it on this, and I don't need to go and check and make sure, oh, I wonder if this server has the appropriate dependencies so that I can deploy my application. I don't need to worry about that. All I have to worry about is to make sure that my app, it's packaged into an image, and in that image I control, well, these are the things my app is going to need. I put all of that in the image, and then I just give that image to Kubernetes. And I know that as long as this is an image, Kubernetes can take that, and then Kubernetes keeps track of, okay, where should I deploy this image? And this is a very, very simple deployment. There's lots of things that you can control here when you're doing the deployment. And I wanted to show you one more thing here. And what I'm going to do is I'm going to stop that port forwarding. What I'm going to do here is I'm going to switch what is called a context. And what this allows me to do is I can point that kube control, that command line tool, I can point that to a different Kubernetes cluster. And I started off doing this on my local machine. But what I'm doing here is that I switch this to work on a Kubernetes cluster that actually runs in AWS. Okay, it runs in AWS. And what I'm going to do here is I'm going to deploy this into, so this is in the cloud. This is a production cluster that I can deploy to, not just on my local machine. But what I'm going to do here is, I'm going to paste in a command here. I'm going to use this kube control. I'm going to create a deployment. I don't know if you remember that from earlier on. This looks exactly the same as what I did on my local machine. But what I'm going to do here that's a little bit different is I'm going to, so this is the new stuff. I'm going to generate a manifest file. So when I execute this here, it won't actually deploy, but what it will do is it will create that file called swappy.yaml. And if I open that file up, then inside of here, remember I said that we have this thing called a manifest. So inside of here, what I can do is I can go in and I can control a lot of things around how I want my application to be deployed. So one of the things that I can do in here, for example, is I can say, you know what, I don't want one instance of this. I want 10 instances, 10 instances to be load balanced when I deploy this into Kubernetes. So I make that one change. It's called replicas. And now I'm going to use that kube control. And I am now going to say that I want to apply whatever is inside of that manifest file, that swappy.yaml, okay? And what happens now is that if I go ahead and I say get all, you will see that I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 instances running of that one application. They are load balanced, okay? And just like before, when I want to access this, then I need to expose this outside of my Kubernetes cluster. So I'm going to go ahead and I'm going to run this expose command, a little bit different than I did before. What I can do here is I don't need to do that whole port forwarding thing that I did before. Here, because it's in the cloud, I can actually say, hey, go ahead and create a load balancer, an external load balancer. And that's what's going to happen here. And now at this point, you will see that there's going to be a service here. So this here is an external URL that is accessible to anyone. Now, it's not up yet because what happens is I literally just did the deployment. What happens here is that when it deploys these 10 instances, and then I say, hey, create a service, it meaning AWS, it actually goes and provisions a new load balancer. So the reason why this is not accessible yet, it's going to take a few minutes before this becomes accessible. It's because right now it is provisioning, it's deploying a load balancer, external of Kubernetes load balancer. So as soon as that is up and running, I'll come back to this in a bit. As soon as that is up and running, we will be able to access this application from this URL right here. So that's an example of taking an application and just running it by itself, packaging it up as an image, running it the image instance, the container without Kubernetes, taking the image, pushing it into a registry. Once that was done, I deploy. There we go. Here is the application. It is now running, and this one is actually accessible. I can put this in the chat here. You don't have to do this, but if you were to go to that URL that I just put in the chat, it's accessible to all of you. For those of you that are watching the recording of this, it will not be accessible. I'll take this down once the recording is done here because I have to pay for this, right? Since this is now in AWS. All right, so this is a example of getting an application deployed into Kubernetes. And to go back to my little diagram here, the key takeaway is that Kubernetes abstracts away compute and storage. I don't need to be, involved with deploying to certain servers. I don't have to monitor my application. Kubernetes does that for me. It orchestrates the deployment, make sure that things gets deployed correctly, and then it also constantly monitors what's been deployed so that if things go down, it relaunches instances. It can scale things up and down depending on workloads, and it allows me to control a lot of things around, I mentioned like network policies, and storage and load balancing, and that is the basics of working with Kubernetes. Now, when I did this here, it might seem like, well, this seems fairly straightforward. Kubernetes can be complex in a larger environment to set up and configure. Here, everything was up and running. The one thing we need to understand is that some group or a person or several people, they have to actually deploy Kubernetes. And there's lots of options for doing that. You can do it in the cloud. You can use managed Kubernetes or self-managed Kubernetes in the cloud. You can do things on-prem. Again, lots of options for doing Kubernetes deployment. And this is where the certified Kubernetes administration certification comes in very, very handy. So this is a certification from the Linux Foundation. I'm going to take this link and put that in the chat as well. And this is an excellent certification to get you ready for deploying and managing Kubernetes. And it is not an easy certification to pass it unless you have a lot of Kubernetes experience already. It's probably going to take you some time to get prepared for. There's lots of resources available to do so. We provide training courses, and mentioned that at the beginning of this webcast. And the exam itself, it is 2 hours long when you take it, and it is online. This is a very important point to make out. It's online, meaning that you can take it from home, your office if you want to, but you need to be in an environment where it's essentially you, a desk, a chair, and your computer. You can't be in a office environment. Like, you can't see really you can see it's kind of cluttered behind me on this side, but I need to clean up my office. You can't have any paper around. You literally have to take a webcam and sort of show your room and your ceiling and your floor and under the desk sometimes, depending on who the proctor is that is facilitating your exam. And you have to be in an environment where there's no other people around. They want to make sure that it's you taking the exam, that you're not getting any help from anyone else. So just be prepared for, wherever you're going to sit, sort of make sure you can clean out your room and have like nothing on your desk, no like paperwork, piece of paper on the wall, even if it has nothing to do with the exam. And they do have on that link that I gave you quite a bit of information about what's on the exam. These are the main domains, and you can see that most of the questions are going to be around architecture, installation, and configuration. So to pass the exam, you need to have a really good grasp about Kubernetes architecture and Kubernetes deployment. In the class that we teach, we go through that process. We deploy Kubernetes from scratch. We spend a lot of time on Kubernetes architecture and working with Kubernetes administration, troubleshooting. It also requires you to know quite a bit about services and networking. And one of the things that they don't mention here is the exam. It's all done in a Linux environment, and the exam is 100% hands-on, meaning that you might have taken other exams, for other courses, AWS or Microsoft, etc. And some exams you have like multiple choice questions. That's the exam. This exam, it's 100% hands-on, meaning that you will get a question where they say, solve this problem, and then you get a Linux terminal. And the entire exam is in that Linux terminal. And you literally have to, type things out and configure and fix and deploy the appropriate resources, which means that you need to be relatively well versed in Linux as well. Understand, common Linux command to deal with like searching and finding things, and you just navigating around in a Linux environment. And the class that we teach, it prepares you quite well for that. And we also provide a bunch of additional resources. You do get a voucher to take the exam twice. If you fail the first time, you can take it a second time. You also get access to an environment called killer.sh, which is an exam simulator. So it's not the actual questions that you would get on the exam, but it's a simulated exam, and similar types of questions that you will get on the exam. It's a great way for getting up and running and ready for taking the certified Kubernetes admin exam. Another resource that exists is, and this one is free, anyone can use this. It's from the same creators as Killer 8H. I'm going to put this link in the chat. This one is called Killer Coda. And just show you something here real quick. So this is an online resource, and I can go in here and I can, let's pick this one, for example. I can pick sample questions. And this is a relatively good representation of what the exam looks like, where you get a question over here on the left-hand side. It says, hey, you know, I want you to create something, create a config map named something with the content, then you get a terminal over here. So this is access to a Kubernetes cluster, and you then have to actually create the resources. Now, when you do this in these practice environments, then you get, you know, some tips, and you get a solution. They say, you know, this is the actual commands that you would execute. Obviously, on the exam, you are not going to have that available. But if you want to get a feel for sort of, I wonder what this would look like. The exam, I wonder, you know, I just want to get kind of an idea of, you know, how I would, you know, fare on the exam. I just want to be able to get a little bit of a hands-on experience and sort of see if I'm ready for this. Go ahead and visit Killer Code again. It's a free resource, and then you can pick any one of these sample questions here and see if you can solve it. And if you feel that, you know what, this seems fairly straightforward and fairly easy, then you might be, you know, closer to taking the exam. Versus if you go in here and say, you know, I don't even know where to start. Well, then a good thing to do would probably be to go through a class, a course to prepare you for this. So that, my friends, is a bit about working with Kubernetes. And oh, one more thing, I completely forgot. One more thing here that I want to mention is when you take this exam, another thing that's a bit different compared to if you've ever taken other exams is that you're actually allowed to use the Kubernetes documentation on the exam. You're allowed to use anything on the kubernetes.io site. More specifically, the Kubernetes IO documentations. So anything that's available here, you're allowed to use on the exam. Now, that being said, if you don't know Kubernetes, even with this, have access to this on the exam, you're not going to pass. I can guarantee it. You still need to be fairly comfortable working with Kubernetes, even having access to this to pass the exam, but this certainly helps. You don't necessarily need to memorize. Remember, I talked about these manifest files. There's examples of manifest files. This is where you can control how specifics about your deployment. You can find some examples of that here to use. This is also a really good resource for just learning Kubernetes. So for example, here is more specifics about the Kubernetes architecture. So this right here is what I deployed to. I was talking to a Remember, I was using this tool called kubectl. That was the command line tool. And I was talking to a component called the API server. That's what I talk to. So when I send commands, I send that to the API server, and then the API server stores specifics about my deployment in a database called etcd. It's a database. And then it tells my scheduler that, hey, I have something that I want to deploy, and the scheduler figures out which node to deploy on. And then the API server talks to the node, something called a kubelet, and then explains that, hey, I have this thing that I want you to deploy. And then there are things called controllers that are constantly managing, making sure that things are up and running. And let's say if a node goes down, the controller becomes aware of that, and it can spin up another node and make sure that resources that were deployed on that node gets redeployed on the new node that gets provisioned. So that is a bit more about working with Kubernetes and doing Kubernetes deployments. I hope you found this useful, and that is what I wanted to present during this hour. I will stick around here for a little bit, so if anyone has any questions, feel free to type that in the chat, and I'll monitor that. But this is the end of what I wanted to present, so if you feel that you are good to go, then feel free to sign out. I'll see you in the next webinar. Please reach out to us if you have any questions about our Kubernetes courses. Until next time, again, if you have any questions, feel free to stick around. You can put them in the chat, and I will answer anything I see in there. But other than that, thanks very much, everyone.